Williams class. For your arithmetic today, the questions are as follows. 4 times 9, 18 times 9. What is 110 as a Roman numeral? What number is next in the sequence? 44, 56, 67, 78. 3 times 5, 72 divided by 12, half of 120, 7,643 plus 2,321, 6,742, take away 2,611, 96 divided by 12. Here are our answers. 4 times 9 equals 36. 18 times 9 equals 162. What is 110 as a Roman numeral? CX. What number is next in the sequence? 44, 56, 67, 78, 89. 3 times 5 equals 15. 72 divided by 12 equals 6. Half of 120 equals 60. 7,643 plus 2,321 equals 9,964. 6,742 take away 2,611 equals 4,131. 96 divided by 12 equals 8. Our learning objective for today's maths lesson is, can I recognise equivalent fractions? Part 2. So by the end of this, you will have learnt to use a number line to identify fractions. Let's have a quick recap. I would like for you to tell me which one is the odd one out and explain why. So what I would do to work out which one is the odd one out is by working out each fraction, working out what each shape would be as a fraction. So what would the first shape be? If I looked at this one, the one that's coloured green, I would say that is 1, 2, 3, 4, 5. Out of how much? How many do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so that is a fraction, or that as a fraction is 5 out of 10. Right, so if that one's 5 out of 10, let's work out what this shape would be as a fraction. You at home and in the classroom, you can shout out your answer. It would be 1 out of 2, because out of 2 parts, 1 has been shaded in. What about this shape here? It would be 6, because 6 squares out of all the squares are red. They've been shaded in red. How many squares do we have in total? 12. And lastly, what would this shape be as a fraction? 3 out of 5. So which one of these is the odd one out? What would you say? I would say that 3/5 is the odd one out. And the reason why 3/5 is the odd one out is because the other fractions are all showing that the shape has been shaded, or half of the shape has been shaded in. So for this shape here, half of it has been shaded, half of it has been shaded, half of it has been shaded, but with 3/5, half hasn't been shaded, more than half has been shaded. So that is why I would say that is the odd one out. Today, we will be looking at how we can use number lines to help find equivalent fractions. Here are 2 number lines. The first line has been divided into 2, which you can see here. You've got a bar here, which has been coloured in light purple, I would say, and it's been divided into 2 by this line over here. Now, the next number line has been divided into 4, because you can see 4 parts in that pink bar, the light purple, whatever colour you want to call it. So that's 1 part, the second part, third part, and then the 4th part. So, as fractions, what would you write there? For the first number line, I would write 1 out of 2, because where this line is, here, it splits the number line into 2. So if I wanted to then say what number belongs here, I would say 1 out of 2, because I'm just looking at the first half. out of the two parts. So similarly here, what numbers would I write here, or what fractions would I write here, and what fractions would you write? Think about how many parts we have in total. That would be our denominator for all of those fractions. So how many parts has that bar been divided into? 4. So I'm just going to write 4 as the denominator for all of them. And then how many parts did I say we had? So I said we had 4 parts. So when you're going in order on a number line, what number always comes first after 0? 1. So it'd be 1 out of 4, 1/4. Then after that, 2/4, 3/4. Because if, for example, I'm looking at this line over here, right? And I'm saying, what fraction would you put underneath that line? I would see how many parts come before that part, or before that line, which are 1 part here, 2nd part here, and a 3rd part here, which is why I would write 3 out of 4 there. So we've already filled in the fractions. Now let's try and find equivalent fractions. So for example, if I have this being a half, and then I said that this is a quarter, 2/4, and 3/4, and I write it here as well, just to show you where those fractions would go. What would you say out of these 3 fractions is the equivalent of a half? Have a look at both number lines and tell me what is the equivalent of this amount. What would be the same on this, in this number line? Think about what fraction would make you have the same sized bar as the one above. Would it be 1/4? This is 1/4. Is 1/4 the same size as a half? No. Is 2/4 the same size as a half? Yes, because you can see if I was to highlight 2/4 here, which is 2 out of 4, which is this one here, you can see that they are actually the same size. So that is what makes them equivalent. Equivalent is another word for equal. So let's just circle which one is equivalent to a half. It would be 2/4, or 2 out of 4. And a little trick here, boys and girls, if you look here, 2 is half of 4 and 1 is half of 2. So you see a pattern there as well with equivalent fractions. They're split in the same sort of way. Let's complete the missing equivalent fractions here. So the first number line has been done for us, where it's split, the number line has been split into how many parts? 8. You look at the denominator to see that. And our number line has been split by the numerator as well. So it's got 1/8, 2/8 is there, 3, 4, 5, 6, 7, 8. Now what we need to do is complete the missing equivalent fractions. So here, if I move the camera, what number would you write here? Have a look at, all you have to do is just look at these boxes, look directly up to see what the same fraction would be, because this number line starts here and ends here. Similarly, the number line at the bottom starts where that line starts and it ends where that line ends. So the chances of this fraction being the same as this one is certain. You're definitely going to have the same fraction. So we have these 2 boxes to complete. What would this fraction be if you had to look at the fraction on top? 2/8. What about this fraction? What would this fraction be? Look at the fraction above, 4/8. And lastly, what would this fraction here be? 6/8. Fantastic. So what has our number lines been divided by? 8. You just have to look at the denominator, the bottom number of the fraction, to see how many parts our number line has been divided into or by. Now we have to place these equivalent fractions on the number line. So it's a challenging one. We will need to use our multiplication facts for this, but where would you put 1/4, 3/4, a 1/6, a 1/3, and 2/3? Have a go at doing this at home and in the classroom. Now here is a trick that I like to do that maybe will work for you. Have a little think about it. If another method works for you, that's completely fine. This is something I do. Now, I'm going to look at 1/4, okay? Look at the denominator, it is 4. Look at the denominator of the number line that we're working with. What's the denominator? 12. Now, 4 is the denominator of the fraction that we want to put into the number line. Now, question for you. How do I get from 4 to 12. What do I need to multiply to 4 in order to get to 12? So go through your 4 times tables. 4, 8, 12. Stop. How many times have I multiplied? 1, 2, 3 times. So I need to do the same with the top number. I've done 4 times 3 to get 12. So whatever you do to the bottom, you also do to the top. Okay, that's just a rule with fractions. So if I've times by 3 to get to 12, I need to do 1 times 3. What is 1 times 3? 3. So the new fraction I'm working with is 3/12, or actually the equivalent fraction, a fraction that is the same as a quarter, is 3/12. So what you would do then is I would put a quarter where I see 3/12 because they're the same thing. All you've done is change a quarter to 3/12 by multiplying the top and the bottom numbers by 3. So they are equivalent. Let's give you another example. We've got 3/4 there. How do I get from 4 to 12 again? What do I times by 4 to get to 12? 3. So do the same to the top number, the numerator. Do 3 times 3? 9. So look for 9/12. Here we are. So what do I write at the top here? 3/4, which is that fraction here. 3/4 is the same as 9/12. Have a go at the next one for me. 1/6. How do I get from 6 to 12? What do I times by 6 to get to 12? 2. Because if you go through your 6 times tables, 6, 12. I've multiplied twice. So I multiplied the top number by 2 as well. So what's 1 times 2? 2. So this is the fraction I'm looking for on the number line, and I can see it here. So at the top here, I'm going to write 1/6. So as you can see, I've placed this number on the number line, or fraction rather, on the number line. I've placed this fraction on the number line. I've placed this fraction on the number line. Where would you place this one? Have a little think. I would put it here. Because in order to get from 3 to 12, you do 3 times 4. So do 1 times 4, because you do the same to the top. That's 4 out of 12. So I look for that fraction and I write the equivalent, which is 1/3. And lastly, we have 2/3. Where would I put that? I would put it here. Because in order to get from 3 to 12, you multiply by 4. Do the same to the top, multiply 2 by 4, and you should get 8. Then I look for this fraction over here, which is here. So put that as the equivalent fraction. I hope that made sense. If it didn't, we have our lives to talk about it a little bit more, and we also have more practice to do, so that's absolutely fine. Time for your independent tasks. You are going to shade the bar models to represent the fractions. Then you are going to tell me what you notice, and then write another fraction that is equivalent to 1/2. Off you go. Right, let's go through this together. A, shade half of the bar model. So I'm going to shade 1 part of the bar model, because out of 2 parts, I have to shade 1 in, just like that. Part B, shade 2/4 of the bar model. So out of the 4 equal parts, I'm going to shade in 2. Just like that. C, shade 3/6 of the bar model. So out of 6 parts, I'm going to shade in 3. Now, I know I'm colouring in quite roughly, boys and girls, but I'm expecting you to be super, super neat with yours because you'll be doing it on paper. So that's 3/6 there for you. What do you notice? Now, if I was to write what I notice, I would say that a half has been shaded in every time. And you can see that in each fraction, a half has been shaded, because out of 2 parts, 1 has been shaded, and 1 is half of 2. Out of 4 parts, I've shaded in half of 4, which is 2. And out of 6 parts, I've shaded in half of 6, which is 3. So write another fraction that is equivalent to 1/2. All you have to do is just see what bar is the same size as this bar, which is 1/2. What bar is the same size? You could pick out of this one and this one. So I'm going to write 2 actually. 2/4 and also 3/6. And to challenge yourself at home and in the classroom, boys and girls, I'm tempted, or not tempted, I'm interested to see, or curious to see, if you can come up with more equivalent fractions rather than 2 out of 4 and 3 out of 6. Can you come up with another equivalent fraction to a half? Let's try this one. Mo is finding equivalent fractions. He says that 6/8 is equivalent to 4/5. Do you agree with him? Explain your answer. Now let's first start off by shading in however much he's told us to shade in. So he said 6/8 is equivalent to 4/5. So what I'm going to do is shade in 4/5 first. 1, 2, 3, 4. So boys and girls, what I would like for you to do then, to push yourselves, is to draw a number line, draw 6/8, or split the number line into 8 parts, shade 6 of those in, and then have a look to see if Mo is correct. Put your answers onto Tapestry for me to see. Here, let's find the missing numbers. What would the missing numerator be over here? Now I'm going to remind you, actually, no, sorry, we have to do this one first. What would be the missing fraction here? This is 2 out of 14, and then 4 out of 14, and at the bottom here it says 1 out of 7. What would this number fraction be? As you can see by the top, the numerators are going up by 1. So this is 2/14. This would probably be 3/14, 4/14. So at the bottom here, if this is 1/7, this would be 2/7. What would this be? Now a little trick here. Have a look at the first fraction, 2/14. The equivalent fraction is 1/7. How have we gotten there? We've divided the 14 by 2. Because 14 divided by 2 is 7. So then what you do to the bottom, you do to the top. So if you divide 2 by 2, you get 1. So do the exact same thing here. We're going to divide by 2 to get our denominator. So what's 14 divided by 2? 7, good. And then this number, we also have to divide by 2, which would be 2. So our missing fraction there is 2/7. Over here, 3/7. So to find the number at the top, what's the opposite of division? Multiplication. So just like we've done 7 times 2 to get 14, we have to do 3 times 2 to get the numerator, the number at the top. What's 3 times 2? 6. Let's see if you can do the rest here. Have a go. This would be 10 out of 14, just like this would be 5 out of 7. If we move on, this would be 12 out of 14, and this would be 6 out of 7. And here, this would be 7 out of 7. Next fraction at the bottom here, I'm just going to move the camera so you can see it nice and clearly. This fraction, or this number line now, has not been divided into 7 or 14 parts. It's been divided into 5 and 15 parts. Can you fill in the missing fractions there? Have a go. Now here, if we look at this fraction compared to its equivalent here, how do we get from 5 to 15? You multiply by 3. Okay, so what you do to the bottom, you do to the top. So to find out what the numerator is here, you do the exact same thing. Multiply by 3. So what's 2 times 3? 6. Well done. Now see if you can work out the rest. So if the numerator here is 9, the denominator here doesn't change. It would be 15 because the denominator for all of them is going to be 15. Here, what would the numerator be? If it's 6 out of 15ths here, 9 out of 15ths here, it would be 12 out of 15 there. And what would this fraction be? Now remember, we are timesing by 3 here. So if we do 6 times 3, it'll be 18. And then 5 times 3, 15. So our fraction would be 18 out of 15 there. So that is it for our maths lesson for today, boys and girls. It was to recognise equivalent fractions. So hopefully what you've been able to see are some patterns here where you can say 4/7 is the same as 8/14. 3/5 is the same as 9/15. So I hope that was okay to do. If not, then please do mention it in the live session and also on Tapestry or email. I'll see you really, really soon, Williams class. Stay safe.